Welcome back to week 4, and in video 5 we are going to continue on and talk about mass wasting. And in particular, we're going to talk about some of the major types of mass wasting and some of the ways that geologists and engineers evaluate the risk of mass wasting and also ways to minimize that risk. So some of the ways that we classify these mass wasting events is basically what size is the material moving down slope? Is it large, coarse-grained material, or is it fine-grained material? So debris would be huge stuff. Earth flow would be more of like a mud, sand type material. And then the type of motion. So is it free-falling? Is it sliding? Is it flowing? So it's the type of material, the size of the particle, and how it's moving. That's how we determine what the name is. So a great place to look at some descriptions of these is not only your textbook, but also this link here to his publication put out by Scott Burns of PSU and the Doug Amy program. So basically this breaks us down into slides, flows, spreads, and topples or falls. And spreads can a lot of times are very similar to slides or slumping. So slow mass movement includes rock glaciers, solifluction, and creep. We'll talk about those in the next couple videos. Rapid would be fall, slide, slump, and flow. So these are ones that are moving too fast for you to be able to keep up with it. So if you click on this link here and we scroll down, we've got some examples here. Let's zoom in a little bit so we can see these a little bit better. So slides, here we can see we've got the movement of material down slope, and in a transitional or translational slide we have the material staying intact. So we just see a huge block maybe of bedrock, or we see trees standing on this material in place. They haven't been really disturbed. It's just sliding down slope and maybe jumbled up at the very end. Slides that are rotational, we call these slumps, where we see the stair-stepped appearance as the material is kind of rotating and sliding down in this plane. So on both of these images here, what we can see are the toe or the end of the landslide, the toe or the end. We can see the scarp or the top kind of scar left behind, and then this slip plane that we can see in the cross section. And in the translational, it's flat, and in the rotational, it's curved. And some examples of what those might look like. Here we have a couple. This would be a translational slide where the material is just moved horizontally, and then the rotational where you see this kind of stair-stepped pattern in the material that's moving. So flows would be mixtures of water, rock, soil with water. That becomes basically a slurry, and flow is similar to water down slope. And these can be in channels, they can be confined to a river valley, they can be just on a whole side of a mountain. They don't have to be in a channel, it could be either one. But basically the material gets all jumbled up. We don't see any slabs or chunks of material intact. And some pictures of what that might look like. Here we have a few examples. Here's the flow. You can see how it just falls down and spreads out. Here you can see material all jumbled up. This mess after a fire, the stained trees, super high. The material was really, really deep as it slid through this area, very liquidy, and then would have been deposited elsewhere. And then in Dodson on 84, it's a good example of a debris flow where material, large, big chunks of material flowed downslope in a kind of liquidy fashion. And then spreads, very similar to the translational flows and falls. We've got topples and falls, where we have material just basically falling down, free falling, maybe slightly attached or bouncing along the surface. So here's some examples. You usually see this along roads where you have steep cliffs nearby. 84 between Hood River and the Dalles, good example, or between Hood River and Portland. You can see lots of those. So these are some great examples. So basically you're going to be looking at falls, flows, and slides are the three major categories we're looking for, and then the size of the particle, debris, or mud flow are your two categories. And then some more examples here. You can see a slide in this picture, of mud flow, and this, or debris flow in this picture here, and then one of these slumps in Turkey, and then an example of a flow that occurred in Wyoming, Grovant. It's right by Grand Teton. Here you can see the scar on the landscape coming down this valley, and then I'm standing on, in this photograph, the debris that came down this valley. And then in this picture here, this slide was way the heck over here and plugged up this river and created this lake. And you can see some trees in that lake as well. So a lot of times these slides, not only do they create that scar in the landscape, but they can also change what happens around the toe of that slide as well. It can change things quite dramatically. Some of the slower mass movement, you can't really see it happen with the naked eye, but you can see evidence of movement. Creep is the slow movement of material down slope due to freezing and thawing, or expanding and contracting of clays as they become wet and dry. Usually we see fence posts that are tilted at an angle, headstones that are tilted, trees with knees is another good example. The tree wants to keep growing straight up, but the ground is moving underneath it, so you get this curved shape at the very bottom, kind of like a J. And then in urban areas, we can see things like cracked foundations, cracked sidewalks, and streets. And then in more alpine-like environments, we can see these kind of solifluction features that you can see here. It looks like rock material in these kind of loopy patterns, and that's because we have this freezing and thawing that happens over time, and the material is slowly moved down slope. And your textbook goes into some great examples of each of these and describes how they are triggered as well. So how do we prevent these? Well, we prevent them by trying to predict the events. We monitor the water content that might be present and monitoring rainfall. In this area, that's the most common trigger for these mass wasting events. Knowing the geology of the area. So do you have a really steep slope? Has there been construction recently in an area? Has there been mass wasting events in this location in the past? Those are all major things to look for. So don't build in an area that has high risk. That's a big thing to look for. I posted a link to a document that discusses some of the things to look for if you're a homeowner or buying a house. How do you know if your house is at risk? Some really great things to look for. So avoiding and preventing, well, knowing the weather patterns, knowing the geology. We can also, if we know we're in an area that's going to have slides or we're worried about it, we could build man-made structures like retaining walls that have proper drainage installed. Revegetate slopes. In this case here, we've got this kind of mesh, almost like a fence material draped over the side, so that if any things fall, they don't bounce along and go across the road. They get trapped underneath there and just maybe roll down and get collected at the bottom of the slope. Along 84, they're doing a lot of construction between Portland and Hood River. They're removing this overhanging wall. They're putting in rock bolts to help steady that slope so that material doesn't fall off anymore. And they're building some retaining walls in some locations. So knowing the geology of the area is huge, but then also trying to figure out what to do to prevent these events is also pretty important. An example of a disaster that may not have been able to be prevented, there's still litigation going on, trying to decide whose fault this was. This is in the Portland West Hills. Happened in 2008, early in the morning. The wife was home. Neighbor was putting the trash out. A woman remembered hearing some weird noises. The person outside heard some weird cracks and shifts, and she ran out of the house, and the neighbor helped her out of the house as it was falling down the slope. Pretty scary stuff. So some of the problems here is there was a house in this open air space, and there was a house down here at the bottom. The people down here are suing the people up here because they say it was their fault, and then the people that lived up here are suing their insurance company. So there's in the depths of these court cases trying to figure out what happened, what went wrong. There's some ideas. It is wet in the wintertime in Portland. Some people think that maybe their retaining walls weren't built correctly, maybe there's a leaky irrigation system. There's lots of ideas floating around to try to figure out, well, what's going on here. This is a notorious area for mass wasting events, so it's very important for people that live here to properly maintain their properties and drain the slopes so that water doesn't build up over time and cause that slope to become overweighted and decrease the friction so that it flows down slope. The zoo and rose gardens are also built on an old landslide. Pretty interesting. If you're curious about those and you want to go visit, let me know and I can show you what to look for. So those are some mass wasting types and how we control and prevent. I will see you in lab.